Okay, we're on.
Okay, thanks. Hi, everybody. Welcome to the Research Interest Group meeting for the Greater New England area, including all of the US and sometimes other parts of North America. Nice to have you with us. The topic for today is to discuss potential internship projects, specifically for the summer internship period. We are going to have several research interns joining us, and we're interested in doing joint work with other groups in Red Hat and defining joint internships. And we'll be sharing the ideas for those with professors and students and student groups that we work at in other universities around Greater New England and elsewhere. So that's the purpose of today's meeting. Thank you to everybody who entered ideas into the spreadsheet ahead of time. We're going to go through those ideas and give people a chance to talk about them a little bit. If you have more ideas or you want to expand off of something that's in the spreadsheet, I'm going to ask that you add another row to the spreadsheet yourself afterwards, so that I don't have to try and edit the spreadsheet and talk at the same time. So I will post again for people who joined a little bit late, the two links. One to the spreadsheet for people who are in Red Hat and can edit it directly. And another link for the meeting notes, which are editable and public for anyone who wants to add the notes or follow along in the notes. Before we get started going through the spreadsheet, are there any questions or comments or anything like that? Okay, great. Feel free to interrupt me because it's kind of hard to watch in this format while we're going through the spreadsheet and I'm sharing my screen. So just speak up if you want to add a comment or question or whatever. Let me share this screen here. Okay. Can everybody see that spreadsheet? Is it too tiny to read or is it okay?
Good on my end.
You can read? Okay. So I'm just going to go down these in order and discuss what I know about them. And if it's something you submitted, then please speak up. Or if it's something you know more about, please speak up. Some of these projects are already underway, and so they've been listed here with particular students who are working on them, but they're open to having more students working on them. And some of them are new ideas that nobody's working on yet. So the first one is a project for doing student kernel tutorial. This is specifically for either RHEL or Fedora. In this case, the one that was done the last time this was an internship was Fedora. It's an online tutorial, so it's meant to get students interested in operating systems and to give them exercises that they can go through themselves and do. It was last done on Fedora 32, I think, so it needs updating. And it would be interesting to add other options to it for other types of kernels if people are interested in that. The next one is a campus outreach project. This is a project that Sarah was involved in and Jen is also involved in. This particular one is outreach to Boston University because we do a lot of work with the BU Collaboratory at Boston University, but we're interested in outreach to other universities as well. So if people have particular universities that they'd like to work with, this is a good one to either model after or add to the work that an intern is doing here. This tends to be a good internship for someone who's new to computer science or even majoring in a different area, but interested in technology and computers. So that's why the skills are listed are a little bit more general than some of the other skills. I'm not going to go through the skills for each internship because they aren't all filled in. And they're fairly specific, but you should look at that if you're interested in any of these internships. The next one is an operations internship, working as part of the operations team in the Mass Open Cloud and in Operate First. Even though Mass Open Cloud is an infrastructure in Massachusetts owned by BU and Harvard and Northeastern and a little bit of MIT, it's open to any users and anybody who wants to participate in it. So we're looking for interns who are interested in learning to be operators or engineers in operations or site reliability engineers. Number 4. This is a new internship in performance tuning for Red Hat Enterprise Linux. This is a brand new project that's just started up internally at Red Hat. And the question is, how can we use AI and machine learning techniques to tune particular parameters of the kernel? And are there ways to do that more efficiently and easier than the ways that we do it currently? This is a project that Larry Woodman has been coordinating with Sanjay Arora. And there are a lot of student interest in machine learning projects. So this one is fairly advanced. It has to be someone who's got very good skills in machine learning. But if people are interested, this is looking for more students to join. The next one, number 5 from Larry, is an in-depth evaluation of the Unikernel versus Standard Linux Kernel. So this is a project that's a PhD project, and we do internships for PhD students as well as undergrads. This has been going for a couple of years and is continuing, and it's happening at Boston University. Number 6 was one that was suggested last year and is also continuing, which is to expand the error codes that get returned from Linux kernel system calls. This one came directly from the operating system group, and we've been making pretty good progress on it, and it's going to continue for another year. This is another one I think that could use more students if anybody's interested. Number 7, sorry, this is getting to be a bit repetitive, but I just want to get through them all. So wake up if and ask a question if it's getting too dull. Number 7, there's a question about how to provide quality of service for Linux processes. This is mostly related to hardware. So what features are in new kinds of hardware and CPUs that you can take advantage of to try and make sure that processes can be scheduled and deliver a certain controllable either delay or number of cycles or things like that that stay constant through different demands on the system. This is another PhD project. There's number 8, which is to do some more Linux Unikernel work. So this is pretty much in the same vein as the other one, but this is more focused on upstream and what we need to do to get Linux Unikernel in use and get more contributors as an upstream version of a kernel. Number 9, this is another new project, just started up. Larry is coordinating this. This definitely could use more interns. The idea of this is to use Jupyter Books, which is a way of programming experiments, basically, with a graphic interface that also does programming, and using this as a way to write and to give courses. This is happening at BU, and we have one intern who's working on content for that. And it's also being deployed for active use, we hope, in courses coming up soon. So we could use more interns to work there as well. Finally, I got out of the ones that come straight from the research group. So hopefully we'll hear from some other people here. Number 10 came from Jeff Moyer. And this is about Intel Data Streaming Accelerator. So Jeff, I see that you're here. Could you speak some about it?
Sure. So traditional storage uses a DMA engine to transfer data from memory to the storage device. Newer storage types, such as persistent memory, are directly accessible by the CPU. And that means that reads and writes, instead of being offloaded to some DMA engine, now actually consume CPU cycles. And the idea of the data streaming accelerator is to offload the copies to an accelerator so that the CPU can actually do some useful work in the interim. And so you're going to be able to drive deeper queue depths per CPU for persistent memory, for an example. I listed the RAM disk driver here as a first project because it's used a lot in testing and would probably be in a more approachable or accessible target for now. You don't need persistent memory hardware, which is difficult to come by. And it would also be useful because it's used in a lot of testing frameworks, the RAM disk driver, that is. And when the RAM disk driver completes I/O synchronously, meaning in the submission path, which means that a lot of the code paths for file systems are different from what they would be when run against actual devices. So this allows us to test on a RAM disk to get super high performance, but actually mimic a little bit better the performance that you'll see on an actual device. For I put down graduate level project just because I wasn't quite sure what to fill in there. I don't know that. I think we could probably make it more approachable for an undergrad, at least some of the initial steps. So I'm open to discussion there.
So like an undergrad who'd had an operating systems course and
Exactly.
knew a little bit. Okay, yep. So maybe a senior. Any questions about that one from anybody? Okay, that sounds really interesting. There's another one from Larry here about the Unikernel. I'm not going to discuss the Unikernel again. This is just the third intern who's working in the Unikernel. By the way, Larry is on PTO today, so that's why I'm explaining his projects instead of having him do it himself. Okay, next one, number 12, from Fabrizio D'Angelo, who is here.
Hello, mic check.
Yep, sounds good. Go ahead.
Okay, so yeah, first one is about network security, particularly the concept of active defense or cyber deception. So the contribution to this space is basically making an automated system that you can easily deploy into existing infrastructure. Because right now there's a lot of tools available for cyber defense, but you kind of have to set them up yourself, and it's quite a big project. So yeah, we're looking into a way where you can kind of make it more easily added to existing infrastructure, and the main goal is to contribute to that open source threat hunting community, and just increase, I guess, security awareness and get a lot of add to the collection of threat actor information that is out there. And yeah, that's a project that I've already been working on for a bit, and we're actually very close to like just letting attackers get at this system that we've kind of been putting together. And anyway, so yeah, that's that one. And then the next one would be, yeah, it's just a proposed idea. We haven't really started this at all, but it's the idea of using the NS3 network simulator and making a contribution to it via adding more. I guess right now there's no way to simulate IoT devices, and it's, I guess, looking at the way that a network would be interesting because they typically operate in the same range as Wi-Fi and Bluetooth. So by creating like API calls that would let you build IoT networks in this simulator, that could potentially let us study ways to improve throughput between IoT devices. For example, like edge devices, which are very popular. And yeah, it's a space that hasn't really been looked into that much. So it could be interesting what we can see there.
Any questions about either of those? I know NS3 is a very popular topic for graduate student theses. So this is a great idea.
Yeah, and I think it also, since it's simulating networks and it will actually produce packet capture files and things like that, it would also be like a good potential teaching tool for just people more new to networking.
Mm-hmm. So this one is targeted for UMass Lowell because you're working with UMass Lowell already. But would you be open to doing it with other universities as well, or is there something specific about UMass Lowell for this one?
I'm open to working with other universities for either. I mean, this one in particular is Sashank's idea, a cybersecurity professor from UMass Lowell.
Okay.
So, I mean, I don't know how collaborations with other universities would work, but definitely open to it.
Yeah, I just brought it up because there is at Northeastern there's an Internet of Things testbed specifically.
Oh yeah, with Chopness.
Yeah, and we're doing a little bit of work with them, so they might be especially interested in this topic. We can pass it on to them and see. But they also have the ability to connect off to other testbeds that have Internet of Things, either simulators or actual live testbeds as well. So that would be kind of cool. I don't know, is Joel here from the Raspberry Pi group? I don't see him. Nope. Because obviously we have students who are working on Raspberry Pi too at UMass Lowell. So it would be interesting having a comparison here of simulation versus something built with actual Raspberry Pis. That would be fun. Cool. Okay. Thank you, Fabrizio. And thank you, Jeff. Sorry, I forgot to thank you. The next one, number 14. This was from Matt Miller, who's not here. I don't know if anybody else is representing his group in this call. No. Okay. Well, I'll try and summarize it. Basically, the OSPO, Open Source Program Office, and the Fedora group, both of who have worked with us in the past on internships, were interested in doing some more joint Fedora projects. So we had interns in the past who did things like community outreach and tools that made it easier for new people to get used to Fedora or do experiments with Fedora. And we also have some outreach projects actually at UMass Lowell. We have a student project called Friendly Fedora that works specifically on how to do Fedora on laptops. And so we're always interested in those kind of internships to continue with the students who get interested in Fedora or come to us through Fedora and want to continue on with a summer internship or maybe even something longer. So that's what this is, a placeholder for that. If you have anything you're interested in doing with the Open Source Program Office or Fedora, this would be the place for that. There's also a survey that's in process that the OSPO is working on of what open source projects Red Hat people are involved with and how healthy they are. And that's a big data analysis project, and they would be interested in students to help with that as well. The next one is from Brian Profit, who is not here. Anybody from Brian's group? Okay, well, I'll summarize that one too then. The OSPO community management, they have several tools for bringing new projects into open source. So people from either, they were development projects that started somewhere else that are moving into open source, or sometimes companies take code that they've written and move it into an open source project. And so there are several tools and documents and software. We had a intern who worked a lot on templates for doing web services and web hosting for new projects in the last internship period, and they would like to continue with that. And the final one is joint AI projects. There are a couple different people who've proposed AI projects, specifically Tom Ricks and Audrey Resnick. And the idea of these is to use AI/ML as a technique for solving problems in other domains. There's one for packaging up TensorFlow. Oh, sorry, it says tensor packaging, but it should say TensorFlow. And there's several others that will probably be joint internships in applying AI ops and machine learning to the container environment in the mass open cloud. So those are all the ones that people entered into the spreadsheet ahead of time. Are there other ideas that people have who are here who would be interested in talking about them? Are there any questions? Okay, well then it will be a brief meeting today. Thank you all for joining us, and thank you for your good suggestions of internship projects that we can do. I look forward to being able to start a lot of these. I think we have a bunch of great suggestions and probably capability to do a lot of them. So anybody who proposed one, I'll be back in touch with you one-on-one about this. And anybody who's watching this and recording later on, if you have an idea or you have students or you are a student and you're interested, please get in touch. And you can find my email easily on the net, and let us know if you're interested in being part of one of these projects. Thanks. Appreciate your help, everybody.
Thank you.
Thanks, Heidi.
Cheers.
Bye.
Bye.
You can stop recording too.
Yep, and then work on there we go. Stop recording.